welcome to Drawing Hub. This is Sanjana, and in this video we will be continuing with part 2 of Algorithm Analysis and Design Module 1. Okay, in the previous class we have just gone through what characteristics of algorithm are. What all did we learn? We learned about unambiguous. I hope you remember what it is. Right, we learned the characteristics is unambiguous. It has input 0 or more input, output 1 or more output, finiteness, feasibility, independent, efficiency, time, and memory. We learned all these things in the last video. If you have any doubt in the previous session, please go and watch the video if you haven't watched it yet. Now, in this video, we will learn what is system life cycle. As I've told you, we will be learning certain terms which are important you should know in the algorithm analysis and design. So system life cycle. What is a system life cycle? When it starts, when it ends, how does this whole system works? That is system life cycle. We should know that in a system there will be a series of stages, and these series of stages, if after each stage it will be move to the next. There are different approaches for it, like a waterfall model and all, if you must have learned in management of software system. Bohm's model, waterfall model, there are different models. We are not discussing about the models as of now. You just need to know that there are a series of stages, and after for each development, once each stage is developed, it will be moved to the next. And if a system, suppose a system is faulty, or the system that you developed does not work properly or does not work the way you want to, or if you are not getting the result how we are supposed to get, then what will happen? The time and money, all those things will be wasted. So for that, we should have a proper idea on how to work on it. So in system life cycles, there are mainly 5 things you should be knowing. There are 5 stages mainly. First one is requirement stage. Requirement stage is where you should know what are the requirements for developing this system, understanding the information, that is what all inputs are given, what is the output that I am expecting, that is what is the result that I have to produce, and all the description of this input and output details. And it should, multiple cases can occur, so we should know what can happen if this is yes, what can happen if this is no. So like that, to understand all those things, what is the user wants it to be, how should the system be, and that is requirements. Know what the requirement of that system is. That is requirements. The next stage is analysis. In analysis stage, we will begin to break down the problem. We know what is that problem. We are having a problem, we need to solve that problem. Isn't that the main thing? So we have the problem and we are dividing that into manageable pieces. There is 2 approaches for analysis. That one is bottom-up approach. This bottom-up approach is actually a very old and unstructured strategy. How I can just show you the figure on how it comes. Bottom up means it comes from bottom to up. So it will be like this. So many modules will be there, and we'll be connecting those modules to get the final output, or in order to analyze that, we add them together, we integrate those modules to one thing. That is bottom up approach. Specific modules will be there and we'll build them, and then we can go and make a more complex structure, that will be ending at the top. We'll be dividing them. Whereas in that is bottom up approach, similarly we have top down approach. This top-down approach is here. What will happen? Opposite of bottom-up. What will happen? So there will be a program, and the program is divided into manageable modules or manageable segments, like this. The reverse of bottom-up. These are the two methods for analysis phase. Then next thing we need to know, the next stage in the system life cycle is design stage. So now you know what you want, you have given you know what the requirements are, then you analyzed the problem. Now you need to design. You cannot just jump directly into making the code or making the implementation. You need to design, and that is where we use the algorithm phase. We write the algorithm. We have the problem, we need to write the algorithm, and we'll see how that problem can be solved according to the requirement. And there are multiple ways for that. That is the design phase. Then we have the fourth stage in this system life cycle is refinement and coding. After these three stages only, we will move to refinement and coding. We cannot jump directly into coding. So now we have an idea on how we want the system to be. Now we can do the implementation. This is the implementation phase. So we can now implement it. And the final stage is verification. We cannot say that, okay, I have done the code, everything is correct, it will work. No, we need to test that. For that, we have this verification. There are different methods for verification, or we can say different type. Why we are using this verification, one thing why we are using this verification is that this phase will actually know how the correctness proof is. It will help us knowing the correctness proof. It will help the program to can test the program, and if we can check if there are any errors and all. So in verification phase, what are the different types? We can have correctness proof. Okay, correctness proof. Correctness proofs, it can be mathematical techniques. These mathematical techniques means they are time consuming for large projects and all. Correctness, okay, I'm proving that this thing is correct. That is correctness proof. Then we have testing. This is the most common method. Okay, testing. What will the working code is required, and I will have a set of test data. I will put that test data in this code which I have got from all these steps, right? And then I will say that whatever data that I have, a test data, I will be training that. Just like how you train an AI model, you will train that, you will test it, and you'll see if you're getting the right thing. And this test data, it can include all the possible scenarios that can help, and that is exactly how that data will be developed. Then the correctness proof and testing are the two things, and apart from that, you have also error removal. Error removal is where first you need to know if there are any erroneous codes. That is, if all these steps are done properly. The correctness proof and the system test will say that, okay, there are erroneous codes, there are errors in it. And then what we can do, okay, we know that, okay, this particular system is having these errors, these errors, and I can correct it. I can go back to the first step, the second step, third step, the refinement and coding, then I can refine it. That is system life cycle. So in system life cycle, what are the 5 stages? Requirement analysis, then design, refinement and coding, and verification. Then we have another important term that you need to know, that is data structure. You have already learned data structure in your previous semesters, right? Probably in your semester 3, you have learned what is data structure. This algorithm analysis and design is actually a continuation of data structure. You need to know what data structure is. Before knowing, I'll just give you an intro. What is data? Okay, now we have 3 things that you need to know. Data, first question, data, entity, and information. At first look, everything seems to be the same, but no, they are not same. They are all different. First of all, what is data? There is some sort of value is there. Let's say, for example, 34, ABC, 10, 10, 20, 20. Sorry about that. I'll just get it right. Okay. Okay. 20, 20. So these are so many random data. There is nothing, it's a raw value. That is called data. Now, if I'm coming to entity, entity is something which have certain attributes are there. Certain attributes in the sense I can say, in this case, let's say employee. Okay, employee. That is an entity. Employee is an entity over here. And what is information? Information means it is the processed data. Processed data. Data is some raw value and processing it. After processing it, what I get? That is information. For example, I have written here 34. What is 34? We don't know. But here I am saying 34 is the age of the employee ABC who joined on this date. So now these random values have a meaning. That is information. These are the three things: data, entity, and information. Don't get confused between them. Now we should learn, okay, now since you know what data, entity, information is, now we can learn what is data structure. So we have the data and the structural representation. What is it? Structural representation of the logical relationship. Structural representation of the logical relationship between elements of data. That might be a little bit confusing. So what I can say is data structure means collection of data. There are data and collection of those data elements, and it can be characterized so that they can be accessed anytime. And these access functions, there are access functions. This can be used to store and retrieve individual data. And one more thing you need to know, what is store? Basically, data structure is storing these data. That is data structure. You need not think so much about it. Just write it in the proper definition form. I'll be uploading the notes also. You can refer to that. Then, what is data manipulation? Data manipulation, you are doing something with the data. You can edit it, like, okay, those edits, what are the edits? I can either store it, okay, yeah, storing is one. I can alter it, I can modify it, yeah, then I can update it, I can delete it, retrieve it, I can add something onto it, I can insert it. That is data manipulation. And now data structure, there are mainly of two types: linear and non-linear type. Non-linear type. Linear type is where? Linear type means it is arranged in a linear fashion. This is linear. In a line fashion. Non-linear, there is no particular line fashion. So in linear, I can say, okay, again in linear fashion, there are two types. Okay, before that, linear array, linked list, queue, stack, and all are there. Again, in linear data structure, there are two types. One is static. Yeah, static and dynamic. Static, we should know it is not going to move anywhere. It is being just there. So that example for static linear data structure is array, and dynamic linear data structure, linked list. It can be changed, right? That is why linked list, you can edit it. Right? Array means it is fixed like that. There is no change inside it. That is why it is static. Then this is dynamic. Linked list is there. Queue. What is there in queue? Queue can also be, what is it following? First in, first out principle. So it is moving. It can be enqueued and dequeued. Then we have stack. Here also last in, first out protocol it is following. So that can be popped and pushed. It is changing always. So that is dynamic. In nonlinear, we have examples like what trees are, then graph, tables, sets. These are nonlinear data structure. So this is it for today's class. I hope everything is clear. If you have any doubts, please let me know in the comment section. We'll learn the rest in the next video. So till then, bye bye.